One of the mysteries about the Mississippi Alluvial Plain, or MAP, is how much waters its streams provide for recharging the MAP's alluvial aquifer. Scientists with the USGS are hoping new research tools can provide answers to the question, as Dr. J.R. Rigby discussed in a presentation for the Virtual Arkansas Soil and Water Education Conference.
In addition, one thing that we didn't have in mind when we first flew the Airborne, but has subsequently been a very interesting venture, is that we flew some of the rivers in the region to see what the bed of the river looked like in terms of bed material. On the left, you can see a map of all the rivers that were included in the original MIRAS regional groundwater study. It's about 43 rivers. And there was, at the time, no information on the bed material from those rivers to help guide the calibration of the groundwater model to understand how much water was moving from the river into the aquifer or vice versa. Like I said, when we started the surveys, we flew some of the rivers just having the helicopter fly along the river so that we would get a picture of the bed material. What we realized, though, is with 50,000 line kilometers of east-west flight lines, we could just take those lines and select the points that occurred over the rivers and use that to map out the rivers. So the figure on the right has taken the NHD plus flow lines that exist as a USGS database and intersected those with our flight lines, and it gives us a much denser network of streams with information about the bed material. So everywhere you see a stream mapped in that figure on the right, we also have information from the airborne data, and the blues and the yellows are represent an index that we developed to estimate whether we think there's high conductivity or low conductivity between the river and the aquifer at those points. So this is already light years ahead of where we could have been with the previous model. To wrap up the airborne, one thing we've been conscious of is the return on investment. We've termed this connecting the dots with airborne geophysics, the dots being boreholes in the region. If you look at the figure on the left, that's another representation of the base of the aquifer. That was based on about 10,000 boreholes. It took decades to collect those boreholes, and those were conducted by different groups in different states for different reasons with a wide variety of data quality. And if you add up the total drilling costs, it cost about $200 to $300 million to collect those 10,000 boreholes. On the right, you can see the comparable base of the aquifer. That's based on 17,000 line kilometers, or about 1 million virtual boreholes. It took about 3 months to collect all of those 1 million virtual boreholes, and it cost less than $1 million. So while the absolute cost of airborne is relatively high if you're putting together a survey, the cost per data point is very low, and you get not only a broad coverage with consistent data quality, but you get it at a fraction of the cost of comparable coverage with boreholes. As an add-on with the airborne, we've collaborated with the U.S. Army Corps of Engineers. We did a pilot study about 1.5 years ago to look at the use of airborne data to evaluate the material along the Mississippi River levees. And the Corps has decided to fund a complete survey of the levees. So later this spring or early this summer, we're going to fly lines along the entire lower Mississippi River levee system to help the Corps better target their geotechnical investigations and help the flood fighters know where they need to add clay blankets and that sort of thing.